as we know that, how do I know this particular grammar is free from left factoring is not free from left factoring is because I see the same term I as well as with term I here, which are repeating, right? So it needs to be left factored. So once the particular grammar is left factored, this is the grammar which I ultimately get, right? So by using this particular grammar, I need to work on with the next important steps. So again, you have to check whether this grammar is free from left recursion. Yes and yes is not repeating, yes and a is not repeating, yes dash and e is not repeating, yes dash and epsilon is not repeating, e and b are not repeating. So this grammar is free from left recursion. I and a different, e and epsilon different, b. So it is also free from left factoring also. So the next case is, once you get the left recursion and free from left recursion and free from left factoring, then you have to calculate the first and follow. So first of s is I and a, so I and a. So first of s dash is e and epsilon, first of e is b. I hope we don't have any issues in calculating or finding out the first set here for the given grammar. The second thing is follow of s. Follow of s is first of s dash. First of s dash is e and epsilon, so e. Dollar, why? Because dollar is actually s is actually the starting production. So anywhere s has been repeated? No. So I have s dash. Follow of s dash is follow of s itself. So dollar e, dollar e. So the second thing is, do we have any other s here? And one more thing, here is again another s, and s is follow of s is follow of s dash itself. That means both are same. S dash is following for s, s is depending on s dash. Both will be the same. Then I am left out with another non-terminal, which is e. Follow of e is t. So t will be put up here. Alright. So I hope we don't have any issues in the first and follow set. The next thing is, as you can see here, parsing table is where on x-axis I generate the terminals. This is my terminals, and on the y-axis I put all the non-terminals, right? So s, s dash and e are non-terminals. $I, e, b, a, t, these are terminals, right? Yes. The next thing is, once we prepare the parsing table, that means on the x-axis we have terminals, on the y-axis we have non-terminals. The next important case is filling up with respect to respective productions. So how do I do it? I have to look into the first set and the follow set to fill this parsing table. So go to first set. First of s is I and a. In place of I and a, that is with I, and with respect to a here, I think a, it has not been filled. So what is the production which I tend to give here is, for I, it has to be s tending to iets s dash. S tending to iets s dash. So which is the production here. In the place of a, I have one more term which is s is tending to a, right? So s is tending to a. This is the production which I need to put it over here, right? So s is tending to is a is the production which is missing. And yeah, coming back, s is tending to a is missing. Kindly write it down. In my particular note, it has been missing. S tending to a in the tuple of x-axis of s and a. This particular tuple, this production s tending to a is missing. Kindly note it. Alright, I'm clearing it off. So the second thing is, in s dash is e and epsilon. So with respect to e here, yeah. So with respect to e here, so s tending to e was the production here which was missing. So first of s dash is e and epsilon. So under e, I should have the particular production S dash tending to ES, because this is the condition. But I also have a production S dash tending to epsilon, right? So S dash tending to epsilon, in the sense, what I do is I go to dollar and E. Got it? I hope you understand it. I'll repeat it again. So initially, first of S dash is E and epsilon. So E got a particular production is tending to ES. Fine. So again I have epsilon. If in case I have epsilon, you have to take down the follow also. You have to consider follow also. So for the dollar, I insert a production S dash tending to epsilon, but again I have a production which is E. This is an ambiguity here. This is an ambiguity here, because the production S dash tending to epsilon is sitting on the same place where I also have S dash tending to ES. So I got an ambiguity. Compiler will now have a problem in order to see whether should I consider the first particular statement production or the second production. So ambiguity occurs. Once you get this ambiguity, you have to specify that the grammar is not in LL or LL of 1, because it has multiple entries for the same terminal in a table. In a particular same entry, I cannot have two particular production. So that's where we say that it is not in LL1, but still we cannot stop it here. We have to check whether the particular grammar is working fine with respect to the input, with respect to the inputs. If E1 then E, if E2 then S1 else S2, if B then A else A. This is my second input. Okay, so considering the first input, so we have to solve. The grammar is not in LL of 1, fine, but the other thing is we have to check whether using this grammar can I yield this particular input or not. That's the question. All right. So the next thing is we'll go towards the stack here with the consideration. So okay, so what was the input actually? So if I see here, the input is if E, then if E2. So E1 and E2 is basically B here. Do not get confused here. I hope you people can zoom it. Kindly use zoom, pinch it out so that it gives you a better clarity here. So here, this is I. So this E is nothing but B, right? So IB, oh, it's a different background here. So I, E1 is in the sense it is B, then S, T, if, so again I encountered E2, so E2 in the sense B. Listen here, my input should not have non-terminals, that's why I am rewriting it. That's the only reason I am rewriting it. My inputs should not have a non-terminal, it should only have terminals. E2 is leading to B, that's why I am writing B here. I hope it makes sense now. So IB, T, IB, then that is T. So again after T I have S1. S1 is straight away giving me a result of A. So consider A. So IB, TI, BT, A. Then else is in the sense it is E. Then again I have S2. S2 in the sense again I have to write it as A. Getting? This is the input which actually you can see it here. So IB, TIB, TA, EA and dollar. I hope the concept is clear here. Why exactly I am considering it. Alright. So looking into that particular case here. So what happened? yeah, starting with, so as we all know that stack will be my starting symbol with the dollar, input will be W and dollar. So what is W? W in the sense it is my input. My input. So this is my input. Alright. Anybody has any issues with whatever I'm teaching you now? If you have any issues, kindly let me know. Alright. So moving on. Okay. So as I said, yes and dollar is what I have in the stack, and input and dollar is what I have in the input. So is there any production by making use of S? I yield my I. So yes, the production is S is tending to IETS S dash. That is my first production there. So I'll replace this S by this IETS S dash. So S and S is matching. So pop the contents of I and I. So I'm left out with ETS S dash dollar, the remaining input dollar. The next thing is, can I move from E to B? Of course, I have a production, E tends to B. So E is becoming B. Ultimately, B and B will be popped off because it has been matched. So it has been matched. Remaining is T S S dash dollar, the remaining TIB TA EA. So here T and T, are they matching? Yes. Pop the contents of T in, or it has been matched. So SS dash dollar, IB TA EA is what my input dollar. So next, can I get I by using S? Of course, IET S dash is already there. So I replace it. So I and I will be matched. So once I and I, if they are matched, I need to move further, deleting off with respect to the I. The next thing is ETS S dash dollar is what I am left out, and BTAEA dollar is what I am left out with the input. So from E, can I get B? Yes. Make use of production, E tends to B, and B and B will be matched. Left out with TS S dash dollar, TAEA dollar. Now T and T have been matched. So S dash dollar, but with the input I am left out with AEA dollar. So now S has a production tending to A. So replace S with A, and S and S is matched, so it gets popped out. Left out with S dash dollar EA, but S dash is not yielding me with respect to A. So here I have a problem. I have a S dash. Now I encountered S dash, but S dash, in order to get A, listen here guys, I'll clear it off. S dash should be tending to A, but in my particular table here, S dash with E, should I consider this production or should I consider this production? I encountered a problem. Got it? So S dash with E, I have to replace with which particular production? So should I replace with first one or the second one? This is the problem. So that's where the ambiguity is occurred, whether to push S dash is ES or S dash tends to epsilon. This is for the first input. Got it? So till here it was my first input. So the second input is if E then S else S. So I, E in the sense it is B, T, A, S in the sense it is A, E, A. Right? So IB, TA, EA is what the input. So as it is the same drill here. So starting with respect to the symbol S and dollar, within the input, in the stack it is S and dollar, in the input it is W dollar. So first I don't do anything. So is there any production moving from S to I? Yes. S into IET S dash, replace it. I and I will be matched. So ET S dash dollar, but I have B, make E to B because I have a production E tends to B. B and B will be matched. Again, T S S dash dollar, T A E A, T and T will be matched. So again, S S dash dollar, A E A dollar. So is there any production moving from S to A? Yes, we have S tending to A. So A and A will be deleted. So again I came back with S dollar and E. So the same situation. S dollar to A has two productions. So I have an ambiguity here. I cannot move further for this particular input also. I hope I have made sense here with respect to the example problem. So in this case, it is not in LL of 1 and it is also not yielding me with the input, whatever the case which we saw. Alright. So this is always, you cannot say that the grammar whatever they give will be solved with respect to the parsing table. No, this is an example where it will not solve. I hope you people got this. So do we have any questions here? If not, we'll move on to the next example. Alright, so we don't have any issues. Moving on. So next is again a very good example where we try to understand with an example here. So I have a production S tending to SS plus, SS star or A. By looking into this grammar, you should know whether is it eligible or not. It is not eligible for now because it is having S and S terms as left recursion and left factoring. Why? Because on the right hand side I have the same symbol which is repeating. So remove the left recursion. Once if I remove S tending to A S dash and S dash tending to S plus S dash or S star S dash or epsilon is what I am left out with. So again I have S and S here, so left factoring should also be done. So S tending to A S dash tending to S S dash or epsilon, S dash tending to plus S dash or star S dash is my new grammar. So once I get this particular grammar, calculate the first and follow sets. So first of S is, so first of S is hello, am I audible? Yeah. So first of S is A. So first of S is A. So then first of S dash is, yes, that means A and epsilon. So A and epsilon. First of S dash, S double dash is plus and star. So plus and star. What is follow of S? In order to find out follow of S, look where exactly I have S. I have S here. Follow of S is a non-terminal. So first of S double dash. S double dash is plus and dollar and plus and star. Dollar is because it is a starting production. The next thing is, do I have any other S anywhere? No. So I have, next is S dash. Do I have S dash anywhere? Yes, S dash is here. S dash, follow of S dash is follow of S itself. So copy the same contents here to here. The next thing is, do I have S dash anywhere? Yes, S dash is here. Follow of S dash is again S double dash. So follow of S dash is again S double dash. Okay. So S dash should have whatever is it's there in S double dash. Next thing is follow of S dash, S double dash is follow of S dash itself. So the same term here will also be repeated here. Alright. So as we know about the first and follow set now, we'll prepare the predictive parsing table. So how do I prepare the predictive parsing table? First I get to calculate the first and follow. With the first terms, I'll start inserting the productions. So in x-axis, I have terminals and in the y-axis I have non-terminals. So first of yes is A. So in the production A, I insert the particular production S tending to A S dash. So first of S dash is A and epsilon. So in S dash A, I insert S dash is tending to S double dash. Second thing is, I also have an epsilon. If I have epsilon, you also need to consider dollar, plus and star. One second, I think we have a question here. Audio is disturbed again. No issue. Anyhow, I'm posting the video and it will be, you can go through the particular case there. So as I have I go with the first of S is A. So S of A, I need to insert the production S tending to A S dash. So next is A and epsilon will have production from S dash. So A is where I insert S dash tending to S double dash production, and I also encountered epsilon in the sense the production will be pushed to dollar, plus and star also. So dollar, plus and star. Alright, so again S double dash is plus and star, so plus and star will have the production related to S double dash. Alright, so here the grammar is in LL of 1. Why? Because I don't have duplicate entries in the same tuple. Right, so that makes sense with respect the given grammar is LL of 1 because there are no multiple productions in the each tuple. So once I calculate the parsing table, consider the inputs whatever they have provided. So input here is AA plus A star. AA plus A star, you have to push it towards your input. Alright, and what will be there in my stack? In the stack will be inserting the starting symbol, that is yes, and in the input I have the input symbol and dollar. So in the stack in the stack I push starting symbol or the starting symbol, production and dollar in the stack, and in the input I push the inputs followed by the dollar. Alright, so same thing. So I don't have an action for the first thing. So is there any production leading from S to A? Yes. So here one thing what I can suggest here is, look carefully. I am actually matching this particular table with the parse the input string. So this way also you can do. So I have stack S and dollar, inputs with dollar. Initially I don't have any action. I encountered what? S with A. I encountered S with A. So S with A, what do I have? S should be tending to AS dash. So S is tending to AS dash. So S is happening to AS dash dollar. So A and A will get cancelled. This is how exactly we need to do it. So I am left out with S dash dollar and the remaining input dollar. So S dash with A, what do I have? S dash with A, use this grammar, S dash tending to SS dash. S dash tending to SS dash. S dash is tending to SS dash. This is what it has to do. So this S dash is becoming S double dash, and I have A plus A star dollar, right? So S with A, what do I have? S with A, S tending to AS dash. S tending to AS dash. So S is giving me AS dash, and A gets matched. So I'm left out with S dash, S double dash, dollar, and plus. So S dash with plus, what do I have? S dash with plus, oh, encounter epsilon, make S dash to epsilon. Make S dash to epsilon. I made S dash to epsilon, so I've left out with S double dash and dollar plus A dollar, star dollar. So S double dash with plus, what do I have? S double dash with plus, okay, S double dash plus S dollar. This is how exactly you need to do. So here, by making use of the predictive table, by making use of the predicting table, you need to work out with this parsing the input string. Alright, so let's continue. So what do I have with respect to S dash was having a production with epsilon, so S became epsilon, and S double dash with plus had a production of plus S dash, so plus and plus get matched, and I have S dash dollar, A star dollar, so S dash with A, I have a production S double dash, S dash tending to S dash, so S dash dollar with A, so S with A, I have a production with S tending to A S dash, so I have S tending to A and S dash, A and A gets matched, so I'm left out with S double dash dollar, and with the input star and dollar. So what happens with S dash and plus? So S dash and star, so I have a production S dash tending to epsilon, S dash is made epsilon, remaining with S double dash and dollar, S double dash with star, yes, make use of S double dash tends to star, S dash, and star will get matched, so I'm left out with S dash dollar dollar. Anyhow, I'm left out with S dash dollar and dollar, so I have to be S dash with the particular epsilon, S dash S dash is having an epsilon production. Okay, where did it go? Okay, so S dash is having a production of S dash tending to epsilon, so I make use of that production, and I have dollar and dollar. As I said, if I encounter dollar and dollar, then the string will be accepted. So this is an example for accepted string. Alright, so the input string will be passed for this particular grammar, right? So in the end, you have to write out that the input string is successfully passed. Alright, so I think I have time for another just one more example problem. We'll take up that particular example problem also. So what is the production which I have? So production which I have is S tending to OS1, 0S1 or 01, free from left recursion, but it is not free from left factoring because 0 and 0 are there. So removing 0 and 0, or in the sense removing left factoring, apply the left factoring algorithm here, and I get this. So calculate the first and follow. First of S is 0, first of S dash is 0 and 1, so 0 and 1. So follow of S is dollar and 1, dollar and 1. So what about follow of S dash? Follow of F dash is follow of S itself. So dollar and 1 is what is repeated again. Once you are done with this, prepare your parsing table. So $01 are my non-terminals, terminals, and S and S dash is non-terminal. So go to S. In S, under 0, I should insert this particular grammar. So 0, 0, S tending to 0 S dash. And do I have any other terms? No. So in, this is not dollar, this is S dash. Kindly make it as S dash. So in S dash, first of S dash is 0 and 1. So in 0 and 1, it has tending to the production S dash tending to S1 and S dash tending to 1. Here you might get one confusion. Why did I go for S dash tending to S1 here but not S dash tending to 1? Because S may lead to 0, but if I encounter this condition S dash tending to 1 here, it will not lead me to 0. That's why you should use a bit common sense here, why we need to go for the other production but not with this. Alright, so once I have my predictive parsing table ready, now I work with respect to the input. So what is my input? So input is 0 0 0 1 1 1. So is that the one? So yes. What is the input? 0 triple 0 triple 1 is the input. So 0 0 0 triple 1 is the input, and in other words this is W dollar, and here starting symbol, that is S with dollar. So S with 0, make use of production is tending to 0 S dash. So make use of production is tending to 0 S dash. So 0 S dash I have, 0 and 0 will be matched, and it is gone. So S dash dollar. So S dash with 0, what do I have? S dash with 0, make S dash as S1. Make S dash as S1, and S1 is what replaced. And S with 0, what do I have? S with 0 is 0 S dash. So 0 S dash, and this 0 and this 0 will be matched. So next is S dash $1, 0 triple $1. So S dash with 0, what do I have? S dash with 0, I have S dash tending to S1. So S dash is tending to S1. Where did it go? S dash tending to S1, and S1 is what I have. S with 0 is production, OS dash. So 0 and 0 will be deleted. S dash $1 and $1 is what I am left out. S dash with 1 is 1. S dash is 1 with 1. So 1 and 1 here is deleted. So again this one and this one is also taken or matched. So 1 and 1 will be popped from the stack. So 1 and 1 will be popped from the stack. So I'm left out with dollar and dollar. So as I get dollar and dollar, the string will be accepted. So the input string is successfully passed without any problem. Alright. So I do have another example. Take this example as a homework, and we can see that in the next class.